Alright, here we go again. So did you stay in the sale promotion from the Leetcode Premium? So if you guys are grinding for the Leetcode and trying to find a new job for the next year, I totally recommend you subscribe the Leetcode Premium. So today Leetcode problem is 1262 greatest sum divisible by 3. So we're given an integer array of nums, so we have to return the maximum possible sum of elements of array such that it is divisible by 3. So I have solved this problem in the past before. If I have to describe, this is a very great example of the median question where we can differentiate whether we should use the dynamic programming or whether we should use the greedy algorithm. So in that case, let's try to understand the problem first before I explain the dive into which kind of approach we should use. So according to the example 1, so we are given the integer array. I'm pretty sure these are all positive integers according to the constraint in here. And then that could be the up to the 4,000, 1 to 4,000. And then, so the minimum number should be also there from, yeah, so the length should be the 1 to the 40,000, not the 4,000. And then the constraint will be from 1 to the 10,000 in here. So the approach we need to solve in here is we have to iterate through the numbers in here. So we see the combination of all the sums in the nums array. We can choose the index dash doesn't require no need to be the subarray. We can choose like 3, 6, and yeah, we can just choose like 3, 6, which is 9, that is divisible by 3. But in the requirement, what they want is they want the maximum possible sum. So we need to maximize all the possible numbers in the array, and then that sum of these numbers should be divisible by 3, and then we have to return the total output of that. So according to the example here, so they pick the 3, 6, 1, which is 3, 6, 1, and 8. So total combination of the sum will be 18, and then 18 is divisible by 3. So that's the answer. 18 is written in here. So for example 2, we only have a 4 in here. So I'm pretty sure the 4 is not divisible by 3. So we just return the 0. So for example 3, that is like 1, 2, 3, 4, 4. So we can choose like 1, 3, 4, 4. 1, 3 mean like 4. So 4 times 3, which is 12, that is divisible by 3. So how can we know that we are choosing the correct number in that case? Maybe I will go through like first approach that I can consider is I'm going to use separate the numbers from here, which is the nums. What I want is a 2 array. Let's call like remainder 1. That is everything inside the nums is divisible by 3. We have a remainder of 1. Next is a remainder of 2. Since our arbitrary value, the divisor is 3. That is the reason why we can only design like the remainder could be 1 or 2 or 0. If it is the remainder becomes 0, that is pretty sure it's divisible by 3. So let's do the step-by-step, and for the first approach, I am going to use a greedy algorithm, and we'll explain about how the greedy algorithm works. So let's call like minimum of 1. Yeah, that's much better. So if I call like a minimum of 1, that will be the, okay, that doesn't make sense. Let's call like remainder 1. Remainder 1. So remainder 1 will be like every numbers from the nums array. 1 is divisible by 3 is having a remainder of 1. So we only will take the 2 numbers from nums. Initially we don't know the value, so we're gonna put the max of the integer. The same for the remainder 2. And then what we want to do is I am going to iteration through. So I need the one number in here. Let's go through it for nums and nums. So in here, I'm gonna need the one number called sum, which is going to keep track of what are the numbers happenings when we are iteration through the nums array. So I'm going to increment the sum with the num from each index of the nums array, and then I'm going to check in here if num mod by 3 is having a 3 case. So case 1, which is a remainder of 1, and then case 2, which is a remainder of 2, and then we may have a default, which is a remainder of 0. So for the case 1, the remainder of 1, what I want to do is I'm going to check our number, mean like let's go through with this number like 3, 6, 5, 1, and 8. So pretty sure 3 and 6 are not going to be show up in here. So to receive the remainder of 1, there is only one number here that will show up. So if we receive the remainder of 1, what we're going to check is we are going to check minimum of 1 less index. Why I'm checking the less index in here is that we have a reason. I'm comparing like 1 is less than the max, because initially we don't have any remainder in our remainder array yet. So if it is true, I'm going to update it. How I'm going to update it? So I will simply check like a minimum of 1 will be we are going to update like minimum of 1 of 0 and minimum of 1 of 1. So I want to take the minimum numbers. I just want to keep track of the minimum of the remainders 1 from the given nums array, and then I will compare with the nums. At the end, I'm gonna sort it. So by sorting out, we are receiving like by ascending order. So whatever the numbers in here, it will be sorted out, and then we're going to update to the minimum of 1. So in here, I'm checking like minimum of 1, 0, and 1 is checking like this index and this index. When comparing it, whatever we are receiving the max, we're going to drop the max and we take the minimum values. Yeah. So initially that will be the same, and that will receive the same number. So at the end, it will take the num, which is a 1. So 1 sorted by max will be like this. 1 comma max. Max means the maximum number of the integers. So for the case 2, which is a remainder of 2, will be the same approach. We're going to check like minimum of 2 of 1. Index 1, we're going to check. It is having the same approach like this, like minimum of 2 of 0 and minimum of 2 of index 1. And then we're comparing it with like a num. So the same approach will happen, and we need to sort it out for this one. So after receiving the minimum of 2 by comparing to a 1, I think we're pretty much done with the approach. Okay, I need to show you guys some. Okay, so let's just return the answer in here, just to show you guys how that will work. Let's call like remainder of 1, and then remainder of 2. So if I'm not wrong, the approach, if we go iterate to 3 and 6, where we skip the fight, so the fight will be in here. Let's call like fight, and then 1 will be in here, and then 8 is a remainder of 2. So we have 5, 8 in the remainder 2, and then 1 max in the remainder 1. So that is what we are expecting in here. All right, I'm trying to run it out. So we were trying to focus the XML 1. Let me see what I do around here. All right, so there should be the minimum of 1 instead of the num1. What did I do wrong? Okay, should not be the minimum, it should be the remainder 1. Alright, sorry guys. I was trying to explain with the thing about which minimum should I use, and at the end I'm using the round variables in here. Let's call like remainder 2, remainder 2, remainder 2. That's make more sense to read the variables values. Alright, exactly, that is what we want. So 1 and maximum, which is I don't know what is the array size of the Leetcode private clouds, and then this is a 5 and 8. In here we can calculate the answer almost already. What we can do is we are going to find the mod of the sum by 3. So sum in here is we are gradually iteration of the incrementing the numbers to sum. So if all the sum is combination is divisible by 3, that's pretty simple. We just return the sum. And then that's our base case. So if another case, if it is not divisible by 3, we are having the remainder like 1 or 2. So we need to think something else. How do we think for the something else? We only need the 2 conditions in our case. Mod is 1. If mod is 1, means we have a remainder of 1. So if we have a remainder 1, we need to choose the 2 candidate. So how do we choose the 2 candidate? Let's call like candidate 1. So for the candidate 1, I'm going to compare like minimum of remainder of 1. First index is less than to the integer dot max. We just want to make sure like we have at least one remainder of 1 in the remainder 1 array. If yes, what do? We simply detect the remainder 1 index 0 from the sum. That is our one of the candidate, because after we detect the mod 1 means that is not divisible by 3 and have remainder of 1. So we simply detect the number that is causing the remainder of 1, and that's our one candidate. Next is we still need to consider for the candidate 2. So to think about the candidate 2, why do we need to think about the candidate 2? So I'm going to show you apps in here. In remainder of 2 of the facts index, we just want to check do we have a remainder 2 numbers in here? If yes, and we need to check with the 2 condition, our minimum of 2 of the second index is also less than to the integer dot max. So why are we checking here is we check the 2 number for remainder 2. All of them are not listed in the remainder 2. That means we are checking like the max number is large, means it's true. That means we have at least remainder 2 items. If yes, what do? We simply detect both numbers like remain. Okay, let me make it better for readability. Remainder 2, I am going to detect the remainder 2 first item and remainder 2 second item. Yeah, if there is no remainder 2 items in our array, we just simply choose 0. So what will be our result? That is pretty simple. We have to take the max of candidate 1 and candidate 2. Why do we check the max in here? Since we are dealing with the maximum number, so we want the largest number. That could be the answer for us. If not, we return the 0 in here. So we are comparing like 0 and max. So else, that will be the mod 2 case. So since we don't have a mod remainder of 1, we need to check for the remainder of 2. The same approach, we can simply copy this approach, and then our candidate 1 will be from the remainder 2 of first item is less than to the maximum of the integer. Technically, we're checking the at least we have remainder 2 items in our list? If yes, we just simply deduct the remainder 2 first item from the sum, and that will be our first candidate. For our second candidate, that is a reverse of what we have done above. So remainder 1 of 0 item is less than to the integer of mass and minimal or remainder 1 of first item is less than to the integer of mass. If yes, same to the above solution, we would do like this in here. And then I'm going to update this with the remainder 1. And then remainder 1. Same approach, we will choose the maximum from the candidate 1 and candidate 2. And then we just simply return the answer, and that could be solve our given problem. Yep, I think the approach is the O of n, since we iteration through the numbers of index from each item by items, and since we don't use any other extra space. But you can complain like, wow, about the remainder 1 and remainder 2. These are the limited size array, and we can totally ignore that. That's why I'm calling it O of 1 for the space complexity. And let's try to submit it. And yeah, that solved the problem. So if we check the time complexity, that is O of n. For the space complexity, that would be the O of 1. But I have another better interesting approach, which is using the dynamic programming. So in here, I'm using the greedy algorithm. Let's reset this, and then let's try to use dynamic programming. So if we are using the dynamic programming, that will be more interesting than the previous one. For the dynamic programming, I was thinking like, how about we use a 3 array? 3 array mean like the array include of the 3 items. Let's call like x, x, and x in here. So, wait, that's a very weird naming. Let's just call like 0, 0, 0, because it's a little bit dark quartz. So if we have base key of the 0, 0, 0, 3 items, what I'm going to do is I am going to iterate through that all these given numbers 3, 6, 5, 1, 8, and then I'm going to check the maximum number of the each array. How about I explain why I was writing the code? Let's call like db as a dynamic programming. We have a base array repeating the 0, and then count will be 3. So that simply create the array like this in here. And then that is where the very interesting approach come in. What I'm going to do is I'm going to iterate in the nums and numbers. And what I need is I need to copy the array. Let's call like temporary array. It's a db. Why do I need to copy the array? Okay, so to copy the array, I have a reason for it. Let's call like values in temporary array. And then what I'm going to check in here is my temporary array of values plus num. So technically, how can I simply choose that? So I am creating the array like only include the 3 items for intentionally. Let's go, I have 3 items like this. 1, 2, and 3. And then this is our base case. Similar to the previous greedy algorithm, this is a remainder 0. When we come to here, this will be the remainder 1 because it's index 1. This will be the remainder of 2. And then I'm going to check my values in here, since we are just simply copying our db array, which will be similar to the declaration up above array with the 3 0, and then we going through, and then I'm gonna addition of the values plus num. So nums in here is a 3 in our case. We are trying to follow to this HTML1 approach, and then 3 plus 0 is a 3. So in that case, I'm going to mop that number since we don't want the 3 in our case. So if we mop the 3 with the 3, that is going to be the 0. So the 3 came to this base case in here. And then I'm gonna update with the our value plus num. And okay, I need to choose like value plus num or our temporary array of value plus num divisible by 3, which is we are comparing the key from here. And then we want the maths in here. Why do we want the maths in here? Okay, let me show the HTML of it. And then at the end of the array, I'm going to update the, let's call like return the dp of 0 in answer. All right, let's try to run, and I will show the temporary array in here. Let's try to run it out and see how does the output look like. What do I do around in here? I take the max. Okay, silly me, missing the brace in here. Alright, so what I'm receiving here is every time it's received a 3, and then 3 is come to here, 6 also come to here, same, but still I need to update my dynamic programming in here. Let's call like dp is update with the temporary, and then instead of seeing the temporary, how about we see the dp array in here? That is makes more sense for us. And then that is the answer already. So what I'm doing here is, if I see the 3 in here, so I'm put the 3 in the index 0 because 3 is divisible by 3. If I see the 6 is also divisible by 3. So if I put the 6 plus 3 in here, which is I'm doing technically in here, so we're taking the maximum. And then next step, I am seeing the 5. So 5 is not divisible by 3, which is having the remainder of 2. So we previously have a 9. So 9 plus 5 is a 14. Then I put the 14 at the index of 2 because the remainder of 5 is 2. And the next step, will be the 1. So 1 is not divisible by 3 also. We have a remainder of 1. So at the time, so we have to put the 1 in our case, we still need to find the maximum and we still need to update it. So how do we receive the 15 in here? That's pretty straightforward. So 3 plus 6 is a 9. 9 plus 5 is a 14. 14 plus 1 is a 15. And then we put the 15 in here. And then next step is a 8. So since 8 is not also divisible by the 3, we have a remainder of 2. And then we update all the index in here by this inner loop. That is the reason, and we are taking the first index, which is divisible by 0 as our array. And that will be the answer for us in the dynamic programming. And I just submit, and voila, I think that will solve the problem. And speed complexity will be the O of 1, and time complexity will be the O of n for sure. Since I don't have a Leetcode Premium, I cannot see the space and time complexity. Yeah, that's pretty much for it, and see you in the next one. Bye.